We will now quickly look at large-scale scenarios that go beyond building evacuations. The latest variant of the Exodus suite of software is urbanEXODUS. urbanEXODUS has been specifically designed to cater for large-scale scenarios spanning several kilometers with tens of thousands of people for scenarios involving wildfires, floods, chemical spills, and others. Exodus achieves this by integrating the pedestrian model with the SUMO traffic model and then coupling the evacuation model with hazard model data. As large-scale socio-natural disasters become more frequent and more intense, their effect on life, property, and the environment becomes more and more severe. The 2009 Black Saturday bushfires in Australia led to over 173 fatalities and many injuries. The 2018 wildfires in Greece led to 103 fatalities and many injuries. The widespread floods and wildfires in 2021 throughout Europe led to hundreds of fatalities and many more injured. Further to the human tragedy, these events had a cost of millions in property damages and left the natural and constructed environment severely affected. The unified modeling approach offers a very powerful tool that can represent large-scale events, allowing emergency authorities and incident managers to better plan, train, and respond to these incidents. The data and information that is needed to formulate large-scale scenarios include the map data, the structures that will be represented in the model, the assembly locations and exit routes, the distribution of the population, including its demographic characteristics, the locations of the vehicles, the population's response time distribution, the authorities' notification methods, the standoff distances from the affecting hazard, the evacuation procedures, and the hazard propagation profile. All this information is necessary to properly set up and simulate a large-scale scenario. An example of a large-scale evacuation is shown in this video. The scenario displayed was part of the final demonstration for the Horizon 2020 InPrep project. The modeled scenario involves a road traffic incident between a private car and a bus with tourists. This accident blocked the road at that location, causing heavy congestion on both sides of the road. The tourists were instructed to wait for the next bus, but eventually they decided to walk southwards towards the forested region. Shortly afterwards, a second accident takes place between two private vehicles. The crash initiates a fire. The fire quickly spreads into the forested area and propagates towards the southwest. At this stage, the agents within the stationary vehicles and those in the forested area start evacuating. The first using the main road towards the north exit and the second towards the seafront. Fire data has been inputted into the Exodus model. The fire front and the smoke plume appear as separate contours on the map. At this stage, the agents attempt to evacuate radially away from the fire hazards. Shortly, a seaborne evacuation commences too, with agents assuming to board boats present at the seafront, moving them away from the fire hazard. A simplified flow model is used here to represent evacuation through the boats. As time passes, the fire propagates further into the forested area, trapping some agents near the seafront. For the purposes of the demonstration, these agents are considered to become fatalities as they cannot escape from the area. Additionally, there is fear of a truck carrying LPG stuck in the southern part of the forest area, exploding due to the approaching fire. This prompts the nearby hotels in the adjacent beach areas to commence evacuation through the south exit. In this particular example, the smoke plume included information regarding PM2.5. The model predicted that some agents were exposed to concentrations of PM2.5 that were 17 times over the equivalent of the air quality guidelines mean daily exposure set by the World Health Organization. Exodus is capable of receiving input and providing output to geographical information systems. The input information includes map data, locations of blocked roads, and population distributions. The output that Exodus can provide to GIS includes the visual representation of the pedestrian and vehicle locations over time, population density contours, and numerical output data regarding the evacuation performance, such as assembly or evacuation times, exit route usage, congestion experienced, distance travels, and others. Exodus can be used during the preparedness phase, allowing crisis managers to assess and verify existing evacuation procedures or to examine a variety of what-if scenarios. Exodus can be used for training purposes, helping crisis managers train in evacuation strategies. It can also be used during educational programs to strengthen community risk perception and resilience. Depending on the case, if evacuation performance results can be produced at a rate much faster than real time, Exodus can be used during the response phase, allowing crisis managers to take informed decisions when managing the evacuation. Furthermore, the integration of Exodus with a common operational picture system enhances the situation awareness of crisis managers and may help the management of an incident. Without simulation tools, it is practically impossible to examine such scenarios. It is impossible, especially in large-scale settings, to test and assess and verify the evacuation procedures or determine what the likely outcome of the evacuation process will be. Furthermore, the user's knowledge and experience, which may be scenario or region specific, is augmented, allowing for decisions to be made based on information from the field.